Hi, today we are going to discuss object-oriented programming concept. Now, what is object-oriented programming or OOP? It refers to a type of computer programming in which programmers define the data type of a data structure and also the types of operations that can be applied to the data structure. Object-oriented programming aims to implement real-world entities like inheritance, hiding, polymorphism, etc. in programming. The main aim of OOP is to bind together the data and the functions that operate on them so that no other part of the code can access this data except that function. So in this way, the data structure becomes an object that includes both data and function. Programmers can also create relationship between one object and another. For example, objects can inherit characteristics from other objects. Now, another type of programming is procedure-oriented programming. For example, Fortran, COBOL basics are procedure-oriented programming. Now, what is procedural programming? Now, procedural programming can be defined as a programming model which is derived from structured programming based upon the concept of calling procedures. So basically, this programming type of programming language depends mostly on procedures or functions. Procedural programming is a style of programming where procedures, often called functions, are the main structure feature of programs, and basic data types are the main form of representation of data. And this contrasts with the object-oriented programming, where classes of objects and their methods are the main structural features of programs, and objects, which are instances of those classes, are the main form of representation of data. Now, difference between procedural programming and object-oriented programming. Now, in procedural programming, programs are divided into small parts called function, whereas in object-oriented programming, programs are divided into small parts called object. Procedural programs follows top-down approach, but object-oriented programming follows just the opposite, is bottom-up approach. There's no access specifier in procedural programming, whereas in object-oriented programming, we use private, public, protected, etc. as access specifier. Adding new data to function is not easy. Adding new data to function in object-oriented programming is very easy. Less secure, do not support overloading. More secure and supports overloading. In procedural programming, function is more important than data and based on unreal world. And now in object-oriented programming, data is more important than function and based on real world. And few procedural programming language example is C, Fortran, Pascal, Basic, etc. And object-oriented programming is C++, Java, Python, C#, etc. So, and the entire OOP concept is based on these features: abstraction, polymorphism, inheritance, encapsulation, class, and object. So next we'll continue with this. So now abstraction refers to the act of representing essential features without including the background details or explanations. One good example of abstraction is ATM machine. All are performing operations on the ATM machine like cash withdrawal, money transfer, retrieve, mini statements, etc. But we can't know internal details about the ATM. Same is you can take a car also as an example of abstraction, where you can drive the car, but while driving, what happens inside the car or inside the engine, you cannot, you can't know about it. So data abstraction can be used to provide security for the data from unauthorized methods. There are two ways to achieve abstraction in data: abstract class and interface. Now, encapsulation. Encapsulation is an act of wrapping up of data and methods into a single unit called class. It is one of the most fundamental concepts of OOP. The insulation of the data from direct access by the stray method of program is termed as data hiding. Encapsulation is basically a way of implementing abstraction. Encapsulation is basically denying the access to the internal implementation or knowledge about internals to the external world, while abstraction is giving a generalized view of any implementation that helps the external world to interact with it. For example, car is an abstraction. You don't know internal working of the car, but within car there are subsystems like steering, brake, clutch, etc., which are encapsulated. School bag is another one of the most real examples of encapsulation. School bag can keep your books, pens, etc. In Java, we usually keep instance variables or properties as private and only provide interfaces or methods to access the properties. The properties and the methods that acts on the properties are bundled together into what we call as class. Those who have access to the class can only see the information. Next is inheritance. Inheritance is the process by which objects of one class acquire the properties of the objects of another class. This provides reusability of code. For example, a particular programmer can make use of an existing class by deriving a new class through inheritance. One of the best real-life example of inheritance is child and parent. All the properties of father are inherited by his son. Now in Java, creating a new class, subclass from a base or superclass is called inheritance. Polymorphism. The word polymorphism means having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. The word poly means many and morphs means forms. So it means many forms. And the real life example of polymorphism is a person at the same time can have different characteristics, like a man at the same time is a father, a husband, employee. So the same person possesses different behavior in different situations. This is called polymorphism. Polymorphism allows to define one interface and have multiple implementation. In Java, polymorphism is achieved by function overloading or operator overloading and method overriding. Now, the class and object. Classes and objects are basic concepts of object-oriented programming which revolve around the real-life entities. Java classes and objects are one of the core building blocks of Java applications, frameworks, and API. API stands for Application Programming Interface. Now, object. An object is an identifiable entity with some characteristics, state, and behavior. For example, orange is an object. Its characteristics are spherical in shape and color is orange. Its behavior is juicy and tastes sweet and sour. You can think about other real world example also for objects. Class. A class is a user defined blueprint or prototype from which objects are created. It is a group of objects that share common properties and behavior. For example, we can consider a car as a class that has characteristics like steering wheel, seats, brakes, etc., and its behavior is mobility. But we can say A Creta having a registration number 4654 is an object that belongs to the class car. And now the advantages of OOP are, it is easy to model a real system as real objects are represented by programming objects in OOP. The objects are processed by their member data and functions. It is easy to analyze the user requirement. With the help of inheritance, we can reuse the existing class to derive a new class such that redundant code is eliminated and the use of existing class is extended. In OOP, stands for object-oriented programming, data can be made private to a class, and this principle of data hiding helps the programmer to build a secure program that cannot be invaded by code in other part of the program. With the help of polymorphism, the same function or same operator can be used for different purposes. This helps to manage software complexity easily. Large problems can be reduced to smaller and more manageable problems. It is easy to partition the work in a project based on objects. It is possible to have multiple instances of an object to coexist without any interference. Each object has its own separate member data and functions. I think now you're clear with the concept of OOP and its advantages over procedural oriented programming. And thank you.